Hello everyone, welcome to lecture 4. So in today's class we learn about some important topics. So get set start. First we learn about hardware design principles. There are two principles: simplicity favor regularity and smaller is faster. So use the same format for all instruction like MIPS. Simple and regular design are easier to build and perform better. For smaller is faster. Keep data is small, fast storage like register, obviously not memory. Smaller component like fewer wires or shorter path lead to quite quicker performance. Now let's learn about MIPS. In this future lecture we learn about more details about MIPS. MIPS stands for microprocessor without interlocked pipeline stages. It was developed at Stanford University. Later, it was commercialized by MIPS technology. MIPS is RISC, which means Reduced Instruction Set Computer. Architecture meaning its use a small, simple set of instructions. Its design helps achieve high performance and easy implementation, especially with pipelining. MIPS assembly instructions. Most MIPS instructions work with two source operands, value to operand on one destination operand where the result is stored. It's look like little bit of confusing, but within some minute you clear all the topic because we discuss details about the MIPS. So how MIPS work? MIPS is a assembly language. It's just like our programming language C, C++. It basically work as backend of compiler. So add and subtraction, three operation. So this is the add operation. If we write in a code, so this will be A equal to B plus C. So it basically summation of B and C. Then data is stored in A. For subtraction, this is the same case. It's subtract T0 minus T1 and stored the data in F. If we write this, then this will be F equal T0 minus T1. Register operands. Arithmetic instruction in MIPS use register. This is important because we not using memory, we using register. MIPS has 32 register, is 32 bits wide. They are used for fast access to frequently used data. Register are numbered 0 to 31. So there is the 32 register in here. A 32 bit value is called word in MIPS. So these are the 32-bit register, and every register have the meaning. For 0 register, name is 0 and always equal to 0. 1 register add, which is work for assembler temporary used by assembler. 2 3 v0 v1 return value from a function call. 4 7 a0 to a3 first 4 parameter. So these all the work you can go through this, and after practice more and more you should be memorize all the things. So there is a note, read the note. Register like a0 to a3 and v0 v1 are used for function call. T register used for temporary use, S register for save value. RA is crucial for function return. SP and FP are used to manage the call stack. So for a C program, F equal to G plus H minus I plus J. So you already know we only calculate, this is the calculation. How we calculate? And two source operands we can use maximum two source operand. So for two source operand, this is our source operand, this is source operand, this is source operand, this is source operand, and this is destination operand. So whenever we use MIPS, we only use two source operand. So first we use add z plus ace and store it t0. T0 is a temporary register or variable you already know from this. Here is a t, where is t, aj. There is a t. Temporary variables need to be preserved. So we use t naught in here, and t naught is collect g plus ace, then t1 is collect I plus j, then we subtract t naught minus t1, then we get our desired result. Now let's learn about endianness. Endianness is the order in which bytes are stored in memory. Two main types, big endian and little endian. Stored the most significant byte first at the lowest memory address. So this is the example. Stored most significant byte mean if the this is the value, then it's stored from 1 2 3 4 5 6 7 8. That's how it's work. And little endian, it's opposite of big endian, stores the least significant byte first. So this is the opposite, it is stored from 7 8 7 8 5 6. So this is basically, this is, this take here, this take here, because this is opposite, you know. So that's how little endian work. This endianness used in hardware design, networking and file format. Memory operands. Memory is byte addressed. Each address point to 1 byte, which is equivalent to 8 bits. Words are 4 bytes, 32 bits. 4 into 8, which is 32. Stored at address that are multiple of 4. This means the storage is 0 4 8. After 8 it will be 12, then 16. That's how it's work. MIPS user big endian. The most significant bytes is stored at the lowest address of the word. So there is the another C programming. You can see here there is a variable g which is destination. This is ace, and we have to summation of ace plus a at 8 index. So z in s1, ace in s2, base address of a s3. So this is the variable we take from register. Compiled MIPS code index 8 records offset of 32, 4 bytes per word. So LW, then we take a temporary variable, then 32. 32 is basically we calculate from here, 8 into size of element, 8 into uh, 4, 8 into 4, which is 32, and S3, this is the S3. Because we load from this in a, from the register, we load this value from register. LW mean load word, so we load the value by using this, and this is the formula we can calculate, sorry, can calculate from here. So this is how we load the value. After loading, we have to summation of ace and 8. First we load this value, then we summation using add. We already know that because we discussed few minutes ago. Why offset is 32? So each element in array A is what, which is 4 bytes. Accessing A8 means A 8 into 4, A plus 32. That's how it's 32. So this is the process. We use this. So this mean 32 S3 means go to address S3 plus 32 and load the word. Key parts: S3 base address start from array A, 32 offset to get A8, load word, gets data from memory into a register. We already talk about this. Now talk about SPIM simulation. SPIM is the MIPS simulator. It runs MIP assembly program on your computer. The name SPIM is just MIPS spelled backward. It lets you write, load, and run MIPS assembly code without real hardware. SPIM can read .asm file and execute them directly. So there is a code. First we just copy paste it, then run it and check the code. For use of this compiler, which is SPIM simulator, you can download it, or this is a web version of this simulator. I give in the link in description so you can easily access this. In next class we discuss about the program and a later topic. So that's all for today. See you in the next class.